This is Geometry, Unit 5. We are going to identify special quadrilaterals. So we're going to look at a list of information, and we have to determine what type of quadrilateral we have. So here we have quadrilateral ABCD, and it has both pairs of opposite sides congruent. So can you draw that picture? Do you understand what that's saying? We know it's a four-sided figure because it's a quadrilateral. It has vertices at A, B, C, and D. And they're telling us that we have both pairs of opposite sides congruent. So something that looks like that. What we've seen before, we have this shape. Okay, what types of quadrilaterals meet this condition? There's a whole bunch of quadrilaterals that have this property. Can you name the quadrilaterals? You got to be pushing some quadrilaterals through your mind when you determine this. If a quadrilateral has two sets of opposite sides congruent, then it is a parallelogram. Two sets of opposite sides congruent is always going to be a parallelogram. It might just be a parallelogram like this, or it might have right angles but still have two sets of opposite sides congruent. It might have all four sides congruent. That would still be two sets of opposite sides congruent. This is a rhombus. And now if you turn it to 90 degrees, that would be a square. That's also going to have those same properties. All of these are parallelograms. That's what they have in common. This is a rule of a parallelogram. All right, number 2. We have a quadrilateral JKLM, and it has pairs of opposite angles congruent. So we can draw our shape. We have two sets of opposite angles congruent. We don't know anything about the sides. We only know about the angles. If a quadrilateral has two sets of opposite angles congruent, then it is a rhombus has that property. That is true. You're going to have opposite angles congruent. They're both big angles. And if it got weirder, those are both gigantic angles. These are both very small angles. But even if all the sides are not congruent, it still has that same property. Big angles, smaller angles, those are going to be congruent. These are going to be congruent. So it's going to be a parallelogram. Any of the parallelograms, rhombus, rectangle, square, this is just a parallelogram. It doesn't have any of those special names. They all have that property. We look at the next one. What is the most specific name for this quadrilateral? Your eyes might be telling you one thing, but what's the information telling you? If a quadrilateral has 4 congruent sides, any 4 congruent side quadrilateral is going to be a what? A rhombus. There's our picture of a rhombus. 4 congruent sides. Now, some of you are saying, hey, Mr. Weber, that's looking very much like a square. You're right, that's what your eyes tell you. It looks like a square, but what don't we know? We don't know about those angles. We don't know if those are right angles or not. They don't have boxes in the corner. So it is a rhombus. That we know for sure. If those are right angles, then it's a square. Looks like a square, but we don't know for sure. Number 4, is enough information given in the diagram to show the quadrilateral is an isosceles trapezoid? Let's first decide, is there enough information to show it's a trapezoid? What's got to be true? To be a trapezoid, what do you have? We have consecutive interior angles that are supplementary. Angle G, comma, angle H are supplementary. Because we have that, because we have 2 angles that add up to 180, we know that segment FG is parallel to segment JH. So yes, we have a trapezoid. Do we have an isosceles trapezoid? That's what they're asking. Is it an isosceles trapezoid? Well, it has legs, of course, because that's what a trapezoid has, but I don't know if those legs are congruent. It doesn't tell me. I can't go by it looks like it. but there is another reason. If a trapezoid has congruent base angles, then it is an isosceles trapezoid. We have base angles that are congruent. And if these are supplementary, then these have to be supplementary, or it has to add up to 360. However you want to do it, this is going to be 78. So these are base angles that are congruent also. All right. Number 5. What is the most specific name for this quadrilateral? What do we know for sure? So what you need to do with your eyes is look for the information that they're giving us. They don't give us any tick marks. They don't give us any angle information. They only tell us the lengths of the sides. If a quadrilateral has two sets of consecutive sides congruent, then it is this is a kite. Two sets of consecutive sides congruent is going to make it a kite. We would not say that a rhombus has two sets of consecutive sides congruent. It's true, it does, but we would not say this shape is ever a kite. Okay? It is a rhombus. A rhombus is not a special type of kite. It kind of seems to have some of the same properties, but nope, they don't overlap. Like we can say a square is a special type of rectangle, yes. A square is a special type of rhombus, yes. Because those are all in the same category as parallelogram. Okay, last one. Is there enough information to show this is a rectangle? And you're probably thinking that a rectangle has four sides and four right angles. And I don't have four right angles here. But can you prove? Can you show? Can you deduce that this is a right angle? There's a couple ways to do that. You know that a quadrilateral has to add up to 360 degrees. So 90 plus 90 plus 90 and another 90 makes 360. So yes, that's a right angle. These two sides, or these two angles, are right angles, which makes these two sides parallel to each other, which means these have to be supplementary, which makes that a right angle. That's another way to do it. There's a couple different ways we can be certain that angle D is a right angle. If a parallelogram has at least one right angle, then it is a rectangle. Okay, we know this is a trapezoid. We know this is a parallelogram because it has one set of consecutive angles congruent and another set of consecutive angles congruent. So we know it's a parallelogram. And it has at least one right angle. If you had one, then you can prove the rest.